Hello and welcome back to the channel. This is Abhinav. So finally, after a long time, I am making a video editorial solutions for Codeforces round. So last some 2 months, I was not active. So now I have again started the CP Codeforces and CodeSafe contest. So now there will be the videos on regular basis, okay, of this contest. And this was my contest, I think, after 15 days, and the last contest which I have participated was after some 1 month. So means in these last 2 months I have participated in just one or two CP contests, and that is why my performance is also low in the last contest also, and this contest also, because it basically takes time to again do the back thing, and again you can see that go at that particular level when you are participating consistently for long month, and then you take a break and then you again start. So it basically takes time now, so to again make that thing. So yeah, that's the thing. If we talk about this contest, this is Codeforces round 803, and I have solved 3 problems in this contest. The problem number D, I have spent some 1 hour in this problem D, but I was very close to this problem. Maybe I will make video after this video. I will try to solve. Okay, but yeah, for this video there will be solutions of A, B, and C of Codeforces round 803. Fine. Yeah. So we talk about the first problem. The first 2 problems are basically the first problem was very easy, just based on a XOR concept. The problem number B and C, the problem number B was and C, both were basically based on implementation only. Okay, so now we'll discuss each and every problem. Okay, so first problem number 1. So in this problem, what they have told us that there is an array, okay, A, which has n minus 1 integers, okay, and x is the XOR of that integers. Now what they have told us that then the number x is added to the end of the array A, then the element of the array are sub. Okay, so the thing is that let me just explain you this thing in the whiteboard. Okay, so what is the thing is that they are basically saying just a minute, I have to just fix it. Yeah, okay, so what they are telling us is that we have some n minus 1 numbers given to us. Okay, so let's say that we have a1, a2, a3, okay, and such that we have some up to a n minus 1 numbers given to us, that these numbers are present in that array. Okay, then a new number x will be added to the particular array, and that the value of x was a1 XOR a2 XOR a3 up to XOR a and minus 1. That was the thing. Okay, now if we will just do that thing, then how we can just solve this particular problem. So it will be like that, when we will make this x, we will add this x into this array, okay, then the whole XOR of this array will become 0, because for example the array will that the array is of size 4, n is 4. So first we have n minus 1 element, let's say a1, a2, and a3. These are the 3 elements which we will have. Okay, now we have to add one more element, which is x, and the value of x will be a1 XOR a2 XOR a3. That will be value of. So let's take that 4th element is a1 XOR a2 XOR a3, and that will be given to us. Okay, now they are asking that this is the array given to us, and you have to tell a element, you have to tell a third element, okay, which will be basically the, so that that element is the XOR of the remaining elements. That element is XOR of the remaining elements. Okay, so what we will do is that if we will find the XOR of these 4 elements, it will be 0 only. How it will be 0? When you will XOR it. So there is a property that a XOR a is 0. This is a property. Okay, so this will be cancelled here. It will be 0. It will be 0, and it will be 0. So overall answer will be 0. Okay, and if we will remove any number from this array, if we remove any number, for example we have removed a3, then the XOR of this number will become A3 only, because that A3 cannot be cancelled. So the answer is that the answer will be that we are given with the array of n numbers. Okay, so any of that number can be performed as x. Any of that number can be used as x. Okay, which is like, because we know that you can also check. You can also check that the array which is given to us, if you will find the XOR of its elements, so it will be 0 only. So if we can remove any element from that particular array, any element, it can be first element, second element, anyone. So the remaining XOR will be, the XOR of remaining elements will be equal to that element only. And that will be the answer. Okay. So here you can see that they have to find out what is x. And they are getting multiple values. Basically, that multiple values are all the values of the array. We can take all the values of the array separate. Okay. Because so what I have done here is, you can see that I have just taken the value of n, taken the vector, and then just outputted the first index of the vector. Because we can output any of the index. We can output first, second, third, any index. Okay, because that is the answer. We can output any number from that particular vector. Because if we will extract any number from that vector, the remaining numbers will give the XOR equal to that number. So any number can be performed as the x, Okay, that is what the problem is. Okay. So now let's move towards problem number B. So for this problem B, they are asking that there is n piles of sand where ith pile has ai blocks of sand. The ith pile is too tall if it has sand greater than the sum of its neighboring piles. Okay, that is what we can do. Also we can do, we can pick an integer k, and from that k, what we can do, we are given with basically an integer k, and from that k, what we can do, that we can choose some k consecutive pillars and then increase its sand by 1. Okay, and then increase its sand by 1. That is what we can do. So if we'll just check out this thing, how we can do it. So for example, we have to observe one thing. Okay. So for example, the array given to us is A1, A2, A3, A4, A5. Okay. So first take first case that k is equal to 1. If k is equal to 1, in that case what we can do? In that case we can basically change value of any of the element of this array. We can change value of any of the element of this array, and we can change it by according to what we want. So for example, there is 5 elements in the array. So what we can do? We can make this element greater than the sum of a1 and a3, and we can make this element greater than the sum of a3 and a5. So basically, if value of k will be 1, then we can have maximum of n minus 1 by 2 such elements, so that value of ai is greater than ai minus 1 plus ai plus 1. That will be the same. Okay. If k is 1, then there will be maximum of n minus 1 by 2 such element, and if they are not, we can just increase its value, increase that element value. And in case k is greater than 1, so what we can do? We cannot change, we cannot make any of the number such that it is greater than its neighboring sum. Why? Because whenever, for example, value of k is 2, so when the value of k is 2, we have to take a subarray of size 2. Let's say this is a subarray we are taking. So whenever we are taking a subarray of size 2 or size 3 or size 4, along with that element, its neighboring element is also increasing. Means along with this ai, its ai minus 1 or maybe ai plus 1 is increasing. So that means that this ai cannot, if it is less, then it will always become less only. It cannot be greater. Why? Because if we are increasing ai, so simultaneously ai minus 1 is also increasing, or ai plus 1 is also increasing, or maybe both are increasing based on the value of k. So if k is 1, then at max n minus 1 by 2 elements are there. If k is greater than 1, in that case, that original array will be only the answer. So we can just count such pairs in original array, such numbers in original array such that they are greater than its neighboring array. Okay, this is what we have to do. This is what we have to do. Okay, so now we can just check it here in our code. What we have done is, you can see it is accepted. Okay, so what I have done is that if the value of k is 1, in that case this output n minus 1 by 2, and if it is not 1, in that case just iterate to the array and then just check that if vi is greater than vi minus 1 plus vi plus 1, then just count it and then output that count. That is what we have to do. Okay, that is what we have to do. Fine, great. Okay, now let's move towards the problem number C. Okay, problem number C. Okay, here I have made 2 wrong submissions. Okay, that was also very silly mistake. I have just missing one condition, but yeah, after that I just got it. Okay, so here it is very simple problem. I mean, problem statement is very simple. Okay, the problem is not simple. The problem statement is quite simple. So let me just explain that to you. Okay, the problem statement is what it is saying. Let me just tell you. Okay, so according to the problem statement, it is saying that if in a array there are A, B and C are present, then there should also be present A plus B plus C. Means if 3 integers are present in the particular array, then for each triplet I comma j comma k, its sum should also be present. Okay, that is what it is asking. So now let's understand that how we can solve it. Okay. How we can solve it. Okay, great. Okay, now what we can do here is that we will have this thing. Okay, now let's see that how we can do it. Okay, so first we will have let's say that we have this thing 1 minus 1 0 0 0. So in this case, how we can solve it? We can just take, you can see that 1 minus 1 and 0. If we are taking these 3 numbers, so its sum is 0 only. Its sum is 0 only, and 0 is also present here. So there are 3 cases. The first case is that all the numbers are 0. That all the numbers are 0. Okay. The second case is that there is only one non-zero number. There is only one non-zero number. First, for example, this is the array, or this is the array. In this case also, you will find for each and every triplet, its sum is also present. For example, we are taking 1 0 0, then 1 is present. For example, we are taking 0 0 0, then 0 is present. And in this case also, if you are taking 1 and minus 1, then 1 minus 1 and 0, then its sum is 0 and 0 is present. If you are taking 1 0 0, so its sum is 1, 1 is present. So the third case is that if we have a positive and a negative number and others are 0. So these are 3 cases. First case is all are 0. Third case is there is only one non-zero number. Let's say 1 0 0. Like these 2 cases. And the third case is there is a positive and there is a negative number. That are the cases which we can. The third case is that there can be 2 positive and 2 negative numbers. Just like here, 2 minus 2, 1 minus 1. This was the case which I was missing. Okay. Maybe many of you are missing this case. In this case also you can see that if you are taking any of the triplet, let's say 2 minus 2 1, so its sum will be something 1, and that 1 is present. So if we will take any of the triplet of this particular array, that is present. So in this case, and that can be just max 4 numbers are there, and max 4 numbers can be there. If there is one more 5th number, you can see why we have there should only 4 numbers. That is what how we can check. The thing is that because whenever we have to take a triplet from it in which there are 2 positive and 2 negative numbers, then in that triplet there should be at least 1 positive number and at least 1 negative number present. There should be at least 1 positive number and at least 1 negative number, because there are 2 negative, 2 positive now. So like this in this triplet, there is 1 negative number and 2 positive numbers. There should be at least 1 negative, and that cannot be the case that all the 3 numbers are positive and all the 3 numbers are negative. And that is why the solution is possible. For example, the numbers are 2 minus 2, 1 minus 1, 3 minus 3. Let's say this is the case. In that case, one can take 2, 1 and 3. So sum will be 6. and then 6 should also be present. So one cannot take all the 3 positive numbers and all the 3 negative numbers. In that case, the sum will increase, and we should also have that sum in the array, then the sum of that sum in the array, like that. It will be an infinite array, like that. But if there is a case that in out of the 3 numbers, 2 is negative, 2 is positive, 1 is negative, 2 negative, 1 positive numbers, means basically the overall sum is less than, means it should be present in that array. Fine. So this is the case. So at max 4 numbers should be present in the array. And out of that 4 number, how we can check? We can just simply check for each and every triplet. That for each and every triplet, its sum is present or not. Okay. So here you can see that how I have implemented this thing. So how I have implemented is that, just a minute. Fine. Yeah. So first I have just stored a non-zero numbers into a vector which is x. Okay. And also stored how many zeros are there. Okay. Now if there are zeros, then I will just push at only 1 0 into that array of the extended numbers. Only 1 0, because taking multiple zeros or taking 1 0 is basically equal. To check why, let me just tell you. Okay. I am saying that, for example, our arrays 1, then 0. Then 0 is basically 100 times. Let's say this array is the size of the array is 101. So this 100 times 0 is not required. This 100 times 0 is not required. Let's say array is minus 1, 1 and 0, and then 100 times 0. That is not required. If we will just take minus 1, 1 and 0, then check for this. That will also give the right answer, because others are 0 only. And taking 0, 0, 0 as a triplet, or minus 1, 1, 0 as a triplet, 1 0 is present now. So we can do it. We can take it. Fine. Or we can take 2 zeros at max, like this. Okay, like this we can do. Fine. So similarly, that is what we have done. So here, if zeros are greater than if there are at least 1 0, then we will just push it into the x. So now this x contains all the non-zero elements and a 0 if it is present. Now if this x size is greater than 5, because I have told you that there can be at max 4 non-zero elements, at max 4. So if there is one more 0 and 4 non-zero element, then at max the size will be 5, not more than 5. Okay. And if the size is greater than 5, then return no. Pn means print no. Otherwise, first store the values of that x vector into a map, so that we can know that this value is present, and then check for each and every, here we are checking for each and every pair that its sum is present in the array or not. If it is not present, then return no. Otherwise, just return yes. That is what we are. Okay. So I hope that you have got this problem. Maybe because I am making the video after a long time, so maybe there is some problem. Maybe I have taken some difficulty in explaining you these problems. So just ask me that in the comment section. Okay, and you can also ask me that things in Telegram. Okay, you can just ask that in Telegram. Also, you can connect with me on LinkedIn. So recently I have completed 11,000 subscribers on LinkedIn. You can join it. Also in our Telegram, we have completed some 1,300 plus students are there. In our YouTube, we have 4K plus subscribers, you can see, and you can also follow me on Instagram. Thank you for watching the video. Thank you.